Religion and Science by Bertrand Russell. Produced by Audio Scholar. Your reader is David Case. Religion and Science was first published in 1935, when Bertrand Russell was 63 years old. Remarkably, it represents just the midpoint of Russell's long literary career, which spanned 75 years, until he was 98 years old. Approximately half of the more than 60 books he wrote were written after the publication of Religion and Science. Religion and Science continued an argument which had concerned Russell for most of his life. Russell saw the conflict between religion and science as a conflict between religious authority and scientific observation. Religion claims to embody eternal truths, whereas science starts not from large assumptions, but from particular facts discovered by observation and experiment. He concluded that human welfare is increased by the discovery of scientific truths, and that it is in the interest of the community that such truths should be freely promulgated. To the European intellectual community of the 1930s, threatened by the rise of totalitarianism, the publication of Religion and Science meant the invocation of free thought itself. And now, Religion and Science by Bertrand Russell. First chapter, Grounds of Conflict. Religion and science are two aspects of life, of which the former has been important as far back as we know anything of our human mental history, while the latter, after a fitful, flickering existence among the Greeks and Arabs, suddenly sprang into importance in the 16th century, and has ever since increasingly molded both the ideas and the institutions among which we live. In what follows, we shall not be concerned with science in general, or with religion in general, but with those points where they have come into conflict in the past, or still do so in the present time. These conflicts have been of two kinds. Sometimes they concern religious assertions refuted by scientific observation, which cause difficulty for those who believe. When these assertions have no inherent religious importance, it is not difficult to explain them away, or to avoid controversy. There is, however, a deeper conflict when science controverts some important dogma, or some philosophical doctrine which theologians believe essential to orthodoxy. The disagreements between religion and science were, at first, of the former sort, but gradually became more and more concerned with matters which were considered a vital part of religious teaching. The way in which science arrives at its beliefs is quite different from that of theology. Science starts not from large assumptions, but from particular facts discovered by observation or experiment. From a number of such facts, a general rule is arrived at. This rule is not positively asserted, but is accepted, to begin with, as a working hypothesis. If it is correct, certain hitherto unobserved phenomena will take place in certain circumstances. If it is found that they do take place, that so far confirms the hypothesis. If they do not, the hypothesis must be discarded, and a new one must be invented. However many facts are found to fit the hypothesis, that does not make it certain, although in the end it may come to be thought in a high degree probable. In that case, it is called a theory rather than a hypothesis. A number of different theories, each built directly upon facts, may become the basis for a new and more general hypothesis, from which, if true, they all follow. And to this process of generalization, no limit can be set. Science is always tentative, expecting that modifications in its present theories will sooner or later be found necessary, and aware that its method is one which is logically incapable of arriving at a complete and final demonstration. But in an advanced science, the changes needed are generally only such as serve to give slightly greater accuracy. The old theories remain serviceable where only rough approximations are concerned, but are found to fail when some new minuteness of observation becomes possible. Moreover, the technical inventions suggested by the old theories remain as evidence that they had a kind of practical truth, up to a point. Science thus encourages abandonment of the search for absolute truth and the substitution of what may be called technical truth, which belongs to any theory that can be successfully employed in inventions or in predicting the future. Technical truth is a matter of degree. A theory from which more successful inventions and predictions spring is truer than one which gives rise to fewer. Knowledge ceases to be a mental mirror of the universe and becomes merely a practical tool in the manipulation of matter. But these implications of scientific method were not visible to the pioneers of science, who, though they practiced a new method of pursuing truth, still conceived truth itself as absolutely as did their theological opponents. The conflict between theology and science was a conflict between authority and observation. Those in science did not ask that propositions should be believed because some important authority had said they were true. On the contrary, they appealed to the evidence of the senses and maintained only such doctrines as they believed to be based upon facts which were patent to all who chose to make the necessary observations. The new method achieved such immense successes, both theoretical and practical, that theology was gradually forced to accommodate itself to science. There is, however, one aspect of religion, and that perhaps the most desirable, which is independent of the discoveries of science, and may survive whatever we may come to believe as to the nature of the universe. Religion has been associated not only with creeds and churches, but with the personal life of those who felt its importance. In the best of the saints and mystics, there existed in combination the belief in certain dogmas and a certain way of feeling about the purposes of human life. The person who feels deeply the problems of human destiny, the desire to diminish the sufferings of humanity, and the hope that the future will realize the best possibilities of our species, is nowadays often said to have a religious outlook, however little he may accept of traditional religion. Insofar as religion consists in a way of feeling, rather than in a set of beliefs, science cannot touch it. Perhaps the decay of dogma may, psychologically, make such a way of feeling temporarily difficult, because it has been so intimately associated with theological belief. But this difficulty need not endure. In fact, many free thinkers have shown in their lives that this way of feeling has no essential connection with a creed. No real excellence can be inextricably bound up with unfounded beliefs. And if theological beliefs are unfounded, they cannot be necessary for the preservation of what is good in religious outlook. To think otherwise is to be filled with fears as to what we may discover, which will interfere with our attempts to understand the world. But it is only in the measure in which we achieve such understanding that true wisdom becomes possible. The Copernican Revolution. The first pitched battle between theology and science, and in some ways the most notable, was the astronomical dispute as to whether the Earth or the Sun was the center of what we now call the solar system. The orthodox theory was the Ptolemaic, according to which the Earth is at rest in the center of the universe, while the Sun, Moon, planets, and system of fixed stars revolve round it, each in its own sphere. According to the new theory, the Copernican, the Earth, so far from being at rest, has a twofold motion. It rotates on its axis once a day, and it revolves round the Sun once a year. The theory which we call Copernican, although it appeared with all the force of novelty in the 16th century, had in fact been invented by the Greeks, whose competence in astronomy was very great. Copernicus, who was born in 1473 and died in 1543, has the honor, perhaps scarcely deserved, of giving his name to the Copernican system. After studying at the University of Krakow, he went to Italy as a young man, and by the year 1500 he had become a mathematics professor in Rome. 3 years later, however, he returned to Poland, where he was employed in reforming the currency and combating the Teutonic Knights. His spare time, during the 23 years from 1507 to 1530, was spent in composing his great work On the Revolutions of the Heavenly Bodies, which was published in 1543, just before his death. As it was, he long delayed publication because he feared ecclesiastical censure. Himself an ecclesiastic, he dedicated his book to the Pope, and his publisher added a preface, which may perhaps have been not sanctioned by Copernicus, saying that the theory of the Earth's motion was put forward solely as a hypothesis and was not asserted as positive truth. For a long time these tactics sufficed, and it was only Galileo's bolder defiance that brought retrospective official condemnation upon Copernicus. Now, there is nothing in the Copernican astronomy to prove that we are less important than we naturally suppose ourselves to be, but the dethronement of our planet from its central position suggests to the imagination a similar dethronement of its inhabitants. While it was thought that the sun and moon, the planets and the fixed stars, revolved once a day about the Earth, it was easy to suppose that they existed for our benefit, and that we were of special interest to the Creator. But when Copernicus and his successors persuaded the world that it is we who rotate, while the stars take no notice of the Earth, when it appeared further that our Earth is small compared to several of the planets, and that they are small compared to the sun, when calculations and the telescope revealed the vastness of the solar system, of our galaxy, and finally of the universe of innumerable galaxies, it became increasingly difficult to believe that such a remote and parochial retreat could have the importance to be expected of the home of human beings if humans had the cosmic significance assigned to them in traditional theology. Mere considerations of scale suggested that perhaps we were not the purpose of the universe. Lingering self-esteem whispered that if we were not the purpose of the universe, it probably had no purpose at all. The next great step in astronomy was taken by Kepler, who was born in 1571 and died in 1630, who, though his opinions were the same as Galileo's, never came into conflict with the Church. The first two of Kepler's 3 laws were published in 1609, the third in 1619. The most important of the 3, from the point of view of our general picture of the solar system, was the first, which stated that the planets revolve around the sun in ellipses of which the sun occupies one focus. Kepler's laws, unlike the law of gravitation, were purely descriptive. They did not suggest any general cause of the movements of the planets, but gave the simplest formulae by which to sum up the results of observation. Simplicity of description was, so far, the only advantage of the theory that the planets revolved about the sun rather than the Earth, and that the apparent diurnal revolution of the heavens was really due to the Earth's rotation. Galileo, who was born in 1564 and died in 1642, was the most notable scientific figure of his time, both on account of his discoveries and through his conflict with the Inquisition. His father was an impoverished mathematician, and did his utmost to turn the boy towards what he hoped would prove more lucrative studies. He successfully prevented Galileo from studying mathematics until, at the age of 19, he happened, as an eavesdropper, to overhear a lecture of geometry. He seized with avidity upon the subject, which had for him all the charm of forbidden fruit. The great merit of Galileo was the combination of experimental mechanical skill with the power of embodying his results in mathematical formulae. Galileo discovered that, apart from the resistance of air, when bodies fall freely, they fall with a uniform acceleration, which in a vacuum is the same for all, no matter what their bulk or the material of which they are composed. Throughout the 2,000 years from Aristotle to Galileo, no one had thought of finding out whether the laws of falling bodies are what Aristotle says they are. To test such statements may seem natural to us, but in Galileo's day it required genius. Experiments on falling bodies, though they might vex pedants, could not be condemned by the Inquisition. It was the telescope that led Galileo onto more dangerous ground. Hearing that a Dutchman had invented such an instrument, Galileo reinvented it, and almost immediately discovered many new astronomical facts, the most important of which, for him, was the existence of Jupiter's satellites. They were important as a miniature copy of the solar system, according to the theory of Copernicus. Besides Jupiter's moons, the telescope revealed other things horrifying to theologicians. It showed that Venus has phases like the moon. Copernicus had recognized that his theory demanded this, and Galileo's instrument transformed an argument against him into an argument in his favor. The moon was found to have mountains, which for some reason was thought shocking. More dreadful still, the sun had spots. This was considered as tending to show that the Creator's work had blemishes. Teachers in Catholic universities were therefore forbidden to mention sunspots, and in some of them this prohibition endured for centuries. Galileo was ordered by the Pope to appear before the Inquisition, which commanded him to abjure his errors, which he did. He solemnly promised that he would no longer hold the Copernican opinion, or teach it, whether in writing or by word of mouth. It must be remembered that it was only 16 years since the burning of Giordano Bruno for similar offenses. At the insistence of the Pope, all books teaching that the earth moves were therefore placed upon the index, and now, for the first time, the work of Copernicus himself was condemned. Galileo, however, was of an optimistic temperament, and at all times prone to direct his wit against fools. He set to work to write his Dialogues on the Two Greatest Systems of the World, which were completed in 1630 and published in 1632. But while the scientific world applauded, the ecclesiastics were furious. Galileo was once more summoned to Rome to appear before the Inquisition, which, feeling itself flouted, was in a sterner mood than in 1616. At first he pleaded that he was too ill to endure the journey from Florence. Thereupon the Pope threatened to send his own physician to examine the culprit, who should be brought in chains if his illness proved not to be desperate. This induced Galileo to undertake the journey without waiting for the verdict of his enemy's medical emissary. When he reached Rome, he was thrown into the prisons of the Inquisition and threatened with torture if he did not recant. Galileo, accordingly, publicly and on his knees, recited a long formula drawn up by the Inquisition. Satisfied that the interests of religion and morals had been served by causing the greatest man of the age to commit perjury, the Inquisition allowed him to spend the rest of his days in retirement and silence, not in prison, it is true, but controlled in all his movements and forbidden to see his family or friends. He became blind in 1637 and died in 1642, the year in which Newton was born. The Church forbade the teaching of the Copernican system as true in all learned and educational institutions that it could control. Works teaching that the earth moves remained banned till 1835. Although the theologians, after their disastrous victory over Galileo, found it prudent to avoid such official definiteness as they had shown in that instance, they continued to oppose science as far as they dared. Demonology and medicine. The scientific study of the human body and its diseases has had to contend, and to some extent still has to contend, with a mass of superstition, supported until modern times by the whole weight of ecclesiastical authority. Disease was sometimes a divine visitation in punishment of sin, but more often the work of demons. It could be cured by the intervention of saints, either in person or through their holy relics, by prayer and pilgrimages, or, when due to demons, by exorcism and by treatment which the demons, and the patient, found disgusting. We now know that certain kinds of diseases can be cured by faith, while others cannot. No doubt miracles of healing do occur, but in an unscientific atmosphere, legends soon magnify the truth and obliterate the distinction between the hysterical diseases which can be cured in this way and the others which demand a treatment based upon pathology. plagues and pestilences, which were common and terrible in the Middle Ages, were attributed sometimes to demons, sometimes to the wrath of God. A method of averting God's anger, which was much recommended by the clergy, was the gift of lands to the church. In 1680, when the plague raged at Rome, it was ascertained that this was due to the anger of Saint Sebastian, who had been duly neglected. A monument was raised to him, and the plague ceased. The Black Death in 1348 caused outbreaks of superstition of various sorts in various places. One of the favorite methods of appeasing God's anger was the destruction of Jews. In Bavaria, 12,000 are reckoned to have been killed. In Strasbourg, 2,000 were burnt, and so on. Not only were superstitious methods of combating disease universally believed to be effective, but the scientific study of medicine was severely discouraged. Anatomy was considered wicked, both because it might interfere with the resurrection of the body, and because the Church abhorred the shedding of blood. Dissection was virtually forbidden. Pope Pius V, in the latter half of the 16th century, renewed earlier decrees by ordering physicians first to call in the priest, on the ground that bodily infirmity frequently arises from sin, and to refuse further treatment if the patient did not confess to the priest within 3 days. Perhaps he was wise in view of the backward condition of medicine in those days. Theological prejudices reappear when awakened by any startling novelty. Inoculation against smallpox aroused a storm of protest from the Church. Many Scottish ministers joined in a manifesto saying the inoculation was endeavoring to baffle a divine judgment. So late as 1885, when there was a severe outbreak of smallpox in Montreal, the Catholic part of the population resisted vaccination, with the support of their clergy. However, the effect in diminishing the death rate from smallpox was so notable that theological terrors have failed to outweigh fear of the disease. The treatment of mental disorders, as may be imagined, was peculiarly superstitious, and remained so longer than any other branch of medicine. Insanity was regarded as due to diabolical possession. Sometimes a cure could be effected by exorcism, or by touching a relic, or by a holy person's command to the demon to come forth. Sometimes elements which savor of magic were mixed with religion. It came to be thought that the best way to drive out the evil spirit was to torture it, or to humiliate its pride, since pride was the source of Satan's fall. Foul odors were used, and disgusting substances. The formula of exorcism became longer and longer, more and more filled with obscenities. By such means, the Jesuits of Vienna, in 1583, cast out 12,652 devils. When, however, such mild methods failed, the patient was scourged. If the demon still refused to leave him, he was tortured. For centuries, innumerable helpless lunatics were thus given over to the cruelty of their barbarous jailers. Even when the superstitious beliefs by which cruelty had originally been inspired were no longer accepted, the tradition survived that the insane should be treated harshly. The harm that theology has done is not to create cruel impulses, but to give them the sanction of what professes to be a lofty ethic, and to confer an apparently sacred character upon practices which have come down from more ignorant and barbarous ages. The intervention of theology in medical questions is not yet at an end. Opinions on such subjects as birth control and the legal permission of abortion are still influenced by biblical texts and ecclesiastical decrees. See, for instance, the encyclical on marriage issued a few years ago by the Pope. Those who practice birth control, he says, sin against nature and commit a deed which is shameful and intrinsically vicious. As regards the interruption of pregnancy for medical reasons, that is, when it is considered necessary in order to save the woman's life, he states, "What could ever be a sufficient reason for excusing in any way the direct murder of the innocent? Thou shalt not kill." It is difficult to resist the conclusion that, to many men, there is something enjoyable in the sufferings of women, and that therefore there is a propensity in men to cling to any theological or ethical code, which makes it a woman's duty to suffer. Although, as we have just seen, theology still tries to interfere in medicine, over most of the field the battle for the scientific independence of medicine has been won. No one now thinks it impious to avoid pestilences and epidemics by sanitation and hygiene, and though some still maintain that diseases are sent by God, they do not argue that it is therefore impious to try to avoid them. The consequent improvement in health and increase of longevity is one of the most remarkable and admirable characteristics of our age. Even if science had done nothing else for human happiness, it would deserve our gratitude on this account. Evolution. The sciences have developed in an order the reverse of what might have been expected. What was most remote from ourselves was first brought under the domain of law, and then gradually what was nearer. First the heavens, next the earth, then animal and vegetable life, then the human body, and last of all, as yet very imperfectly, the human mind. In this there is nothing inexplicable. Familiarity with detail makes it difficult to see broad patterns. The outlines of roads are more easily traced from an aeroplane than from the ground. A person's friends know what he is likely to do better than he does himself. At a certain turn in the conversation, they foresee the dreadful inevitability of one of his favorite anecdotes, whereas to himself he seems to be acting on a spontaneous impulse, by no means subject to law. The detailed acquaintance derived from intimate experience is not the easiest source for the generalized kind of knowledge which science seeks. Not only the discovery of simple natural laws, but also the doctrine of the gradual development of the world as we know it, began in astronomy. But the latter, unlike the former, found its most notable application in connection with the growth of life on our planet. The doctrine of evolution, which we are now to consider, though it began in astronomy, was of more scientific importance in geology and biology, where, also, it had to contend with more obstinate theological prejudices than were brought to bear against astronomy after the victory of the Copernican system. It is difficult for a modern mind to realize how recent is the belief in development and gradual growth. It is, in fact, almost wholly subsequent to Newton. The doctrine of the gradual evolution of plants and animals by descent and variation, which came into biology largely through geology, may be divided into three parts. There is first the fact, as certain as a fact about remote ages can hope to be, that the simpler forms of life are the older, and that those with a more complicated structure make their first appearance at a later stage of the record. Second, there is the theory that the later and more highly organized forms did not arise spontaneously, but grew out of the earlier forms through a series of modifications. This is what is meant by evolution. Third, there is the study, as yet far from complete, of the mechanism of evolution, that is, of the causes of variation and of the survival of certain types at the expense of others. The general doctrine of evolution is now universally accepted among biologists, though there are still doubts as to its mechanism. The chief historical importance of Darwin lies in his having suggested a mechanism, natural selection, which made evolution seem more probable. But his suggestion, while still accepted as valid, is less completely satisfying to modern science than it was to his immediate successors. Darwin's theory was essentially an extension to the animal and vegetable worlds of laissez-faire economics. All living things reproduce themselves so fast that the greater part of each generation must die without having reached the age to leave descendants. A female codfish lays about 9 million eggs a year. Even human populations, though their rate of natural increase is slower than that of any other animals except elephants, have been known to double in 25 years. If this rate continued throughout the world for the next 2 centuries, the resulting population would amount to 500 billion. But we find, in fact, that animal and plant populations are, as a rule, roughly stationary. And the same has been true of human populations at most periods. There is, therefore, both within each species and as between different species, a constant competition, in which the penalty of defeat is death. It follows that if some members of a species differ from others in any way which gives them an advantage, they are more likely to survive. If the difference has been acquired by learning, it will not be transmitted to their descendants. But if it is congenital, it is likely to reappear in at least a fair proportion of their posterity. As often happens, the theologians were quicker to perceive the consequences of the new doctrine than were its advocates, most of whom, though convinced by the evidence, were religious men, and wished to retain as much as possible of their former beliefs. Progress, especially during the 19th century, was much facilitated by lack of logic in its advocates, which enabled them to get used to one change before having to accept another. When all the logical consequences of an innovation are presented simultaneously, the shock to habits is so great that people tend to reject the whole, whereas if they had been invited to take one step every 10 or 20 years, they could have been coaxed along the path of progress without much resistance. The theologians, however, saw what was involved more clearly than did the general public. They pointed out that people have immortal souls, which monkeys have not, that people have a divinely implanted sense of right and wrong, whereas monkeys are guided solely by instinct. If humans developed by imperceptible steps out of monkeys, at what moment did they suddenly acquire these theologically important characteristics? Religion, in our day, has accommodated itself to the doctrine of evolution and has even derived new arguments from it. We are told that evolution is the unfolding of an idea which has been in the mind of God throughout. But the same laws which produce growth also produce decay. Someday the sun will grow cold, and life on the earth will cease. The whole epoch of animals and plants is only an interlude between ages that were too hot and ages that will be too cold. There is no law of cosmic progress, but only an oscillation upward and downward, with a slow trend downward on the balance owing to the diffusion of energy. This, at least, is what science at present regards as the most probable, and in our disillusioned generation it is easy to believe. Soul and body. Of all the more important departments of scientific knowledge, the least advanced is psychology. According to its derivation, psychology should mean the theory of the soul. But the soul, though familiar to theologians, can hardly be regarded as a scientific concept. No psychologist would say that the subject matter of his study is the soul. But when asked to say what it is, he would not find it easy to give an answer. Some would say that psychology is concerned with mental phenomena, but they would be puzzled if they were required to state in what respect, if any, mental phenomena differ from those which provide the data of physics. Fundamental psychological questions quickly take us into regions of philosophical uncertainty, and it is more difficult than in other sciences to avoid fundamental questions because of the paucity of exact experimental knowledge. Nevertheless, something has been achieved, and much ancient error has been discarded. Much of this ancient error was associated with theology, either as cause or as effect. But the connection was not with particular texts or biblical errors of fact. It was rather with metaphysical doctrines which, for one reason or another, had come to be thought essential to the body of orthodox dogma. The soul, as it first appeared in Greek thought, had a religious origin. It seems to have originated in the Pythagoreans, who believed in transmigration, and aimed at an ultimate salvation which was to consist of liberation from the bondage of matter, which the soul must suffer so long as it is attached to a body. According to the philosophical orthodoxy of the Roman Catholic Church, soul and body are both substances. A substance is something other than the sum of its attributes. This appears most clearly in the Catholic doctrine of the Eucharist. In transubstantiation, the attributes of the bread remain, but the substance becomes that of the body of Christ. In the period of the rise of modern philosophy, all the innovators from Descartes to Leibniz, except Spinoza, took great pains to prove that their doctrines were consistent with transubstantiation. Take first the body. So long as the conception of substance was retained, the resurrection of the body meant the reassembling of the actual substance which had composed it when alive on earth. The substance might have passed through many transformations, but had retained its identity. If, however, a piece of matter is nothing but the assemblage of its attributes, its identity is lost when the attributes change, and there will be no sense in saying that the heavenly body, after the resurrection, is the same thing that was once an earthly body. This difficulty, oddly enough, is exactly paralleled in modern physics. An atom, with its attendant electrons, is liable to sudden transformations, and the electrons which appear after a transformation cannot be identified with those that had appeared before. Each is only a way of grouping observable phenomena, and has not the sort of reality required for the preservation of identity through change. The results of the abandonment of substance were even more serious as regards the soul than as regards the body. They showed themselves, however, very gradually, because various attenuated forms of the old doctrine were, for a time, thought to be still defensible. First, the word mind was substituted for the word soul, in order to seem to avoid theological implications. Then the word subject was substituted, and this word still survives, particularly in the supposed contrast of subjective and objective. In human physiology, meanwhile, those who disliked materialism took refuge either in mystery or in the vital force. Some thought that science could never understand the human body. Others declared that it could only do so by invoking principles other than those of chemistry and physics. Neither of these views has now much popularity among biologists. The work which has been done in embryology, in biochemistry, and in the artificial production of organic compounds makes it more and more probable that the characteristics of living matter are wholly explicable in terms of chemistry and physics. As psychology and physics became more scientific, the traditional concepts of both gave way increasingly to new concepts capable of greater accuracy. Physics, until very recently, was content with matter and motion. But matter and motion have now been found inadequate even technically, and the procedure of theoretical physicists has come much more into line with the demands of scientific philosophy. Psychology, in like manner, is finding it necessary to give up such concepts as perception and consciousness because it is found that they are incapable of precision. To make this plain, a few words about each will be necessary. Perception seems, at first sight, perfectly straightforward. We perceive the sun and moon, the words we hear spoken, the hardness or softness of the things we touch, the smell of a rotten egg, or the taste of mustard. There is no doubt about the occurrences of which we give this description. It is only the description that is questionable. When we perceive the sun, there has been a long causal process, first in the 93 million miles of intervening space, then in the eye, the optic nerve, and the brain. The final mental event, which we call seeing the sun, cannot be supposed to bear much resemblance to the sun itself. The sun remains outside our experience, and only to be known, if at all, by a difficult inference from the experience which we call seeing the sun. We suppose that the sun has an existence outside our experience because many people see it at once, and because all sorts of things, such as the light of the moon, are most simply explained by assuming that the sun has effects in places where there are no observers. But we certainly do not perceive the sun in the direct and simple sense in which we seem to do so before we have realized the elaborate physical causation of sensations. To make inferences as to the object from the sort of experience which we naturally call a perception, we must know physics and the physiology of the sense organs, and we must have exhaustive information about what is in the intervening space between us and the object. Given all this information, and assuming the reality of the external world, we can derive some highly abstract information as to the object perceived. But all the warmth and immediacy that are implicit in the word perception will have vanished in this process of inference by means of difficult mathematical formulae. In the case of distant objects, like the sun, this is not difficult to see. But it is equally true of what we touch and smell and taste, since our perception of such things is due to elaborate processes which travel along the nerves to the brain. The question of consciousness is perhaps rather more difficult. We say that we are conscious, but that sticks and stones are not. We say that we are conscious when awake, but not when asleep. We certainly mean something when we say this, and we mean something that is true. But to express with any accuracy what it is that is true is a difficult matter, and requires a change of language. When we say we are conscious, we mean two things. On the one hand, that we react in a certain way to our environment. On the other, that we seem to find, on looking within, some quality in our thoughts and feelings which we did not find in inanimate objects. The more important part of the notion of consciousness is concerned with what we discover by introspection. We not only react to external objects, but we know that we react. To know that we see something is not really a new piece of knowledge, over and above the seeing, unless it is a memory. If we first see something, and then immediately afterwards reflect that we say it, the reflection, which seems introspective, is an immediate memory. Memory, it may be said, is something distinctively mental, but this again may be denied. Memory is a form of habit, and habit is characteristic of nervous tissue, though it may occur elsewhere, for example in a roll of paper, which rolls itself up again if it is unwound. Finally, it should be said that the old distinction between soul and body has evaporated quite as much as matter has lost its old solidity, as because mind has lost its spirituality. The data for both physics and psychology are events which, in some sense, happen in the brain. The facts, which form the starting points of the two sciences, are, at least in part, identical. It remains to inquire what bearing modern doctrines, as to physiology and psychology, have upon the credibility of the belief in immortality. What science has to say on the subject of immortality is not very definite. There is indeed one line of argument in favor of survival after death, which is, at least in intention, completely scientific. I mean the line of argument associated with the phenomena investigated by psychical research. I have not myself sufficient knowledge on this subject to judge of the evidence already available, but it is clear that there could be evidence which would convince reasonable people. The difficulty, for science, arises from the fact that there does not seem to be such an entity as the soul or self. As we saw, it is no longer possible to regard soul and body as two substances, having that endurance through time which metaphysicians regarded as logically bound up with the notion of substance. Nor is there any reason, in psychology, to assume a subject which, in perception, is brought into contact with an object. Until recently it was thought that matter is immortal, but this is no longer assumed by the techniques of physics. An atom is now merely a convenient way of grouping certain occurrences. It is convenient, up to a point, to think of the atom as a nucleus with attendant electrons, but the electrons at one time cannot be identified with those at another, and in any case no modern physicist thinks of them as real. While there was still material substance which was supposed to be eternal, it was easy to argue that minds must be equally eternal. But this argument, which was never a very strong one, can now no longer be used. For sufficient reasons, physicists have reduced the atom to a series of events. For equally good reasons, psychologists find that a mind has not the identity of a single continuing thing, but is a series of occurrences bound together by certain intimate relations. The question of immortality, therefore, has become the question whether these intimate relations exist between occurrences connected with a living body and other occurrences which take place after that body is dead. We must decide, before we can attempt to answer this question, what are the relations which bind certain events together in such a way as to make the mental life of one person. Obviously, the most important of these is memory. Things that I can remember happened to me, and if I can remember a certain occasion, and on that occasion I could remember something else, then the something else also happened to me. Each person's experience is private to himself, and when one experience consists in recollecting another, the two are said to belong to the same person. There is another, less psychological definition of personality, which derives from the body. We can define a person as the series of mental occurrences connected with a given body. If John Smith's body committed a murder, and at a later time the police arrest John Smith's body, then the person inhabiting that body at the time of arrest is a murderer. These two ways of defining a person conflict in some cases with what is called dual personality. In such cases, what seems to outside observation to be one person is, subjectively, split into two. Sometimes neither knows anything of the other. Sometimes one knows the other, but not vice versa. In cases where neither knows anything of the other, there are two persons if memory is used as the definition, but only one if the body is used. There is a regular gradation to the extreme of dual personality through absent-mindedness, hypnosis, and sleepwalking. This makes a difficulty in using memory as the definition of personality, but it appears that lost memories can be recovered by hypnotism or in the course of psychoanalysis. Thus, perhaps, the difficulty is not insuperable. If we are to believe in the survival of a personality after the death of the body, we must suppose that there is continuity of memories, or at least of habits, since otherwise there is no reason to suppose that the same person is continuing. But at this point, physiology makes difficulties. Habit and memory are both due to effects on the body, especially the brain. The formation of a habit may be thought of as analogous to the formation of a watercourse. Now, the effects on the body which give rise to habits and memories are obliterated by death and decay, and it is difficult to see how, short of miracle, they can be transferred to a new body, such as we may be supposed to inhabit in the next life. If we are to be disembodied spirits, the difficulty is only increased. Indeed, I doubt whether, with modern views of matter, a disembodied spirit is logically possible. Matter is only a certain way of grouping events, and therefore, where there are events, there is matter. The continuity of a person throughout the life of his body, if, as I contend, it depends upon habit formation, must also depend upon the continuity of the body. I do not pretend that this argument is conclusive. It is impossible to foresee the future of science, particularly of psychology, which is only just beginning to be scientific. It may be that psychological causation can be freed from its present dependence on the body. But in the present state of psychology and physiology, belief in immortality can, at any rate, claim no support from science, and such arguments as are possible on the subject point to the probable extinction of personality at death. Mysticism. Ought we to admit that there is available, in support of religion, a source of knowledge which lies outside science, and may properly be described as revelation? This is a difficult question to argue, because those who believe that truths have been revealed to them profess the same kind of certainty in regard to them that we have in regard to objects of sense. We believe the person who has seen things through the telescope that we have never seen. Why then, they ask, should we not believe them when they report things that are to them equally unquestionable? It is perhaps useless to attempt an argument such as will appeal to the person who has enjoyed mystical illumination. But something can be said as to whether we others should accept this testimony. In the first place, it is not subject to the ordinary tests. When a person of science tells us the result of an experiment, he also tells us how the experiment was performed. Others can repeat it, and if the result is not confirmed, it is not accepted as true. But many people might put themselves into the situation in which the mystic's vision occurred without obtaining the same revelation. To this it may be answered that a person must use the appropriate sense. A telescope is useless to a person who keeps his eyes shut. The argument as to the credibility of the mystic's testimony may be prolonged almost indefinitely. Science should be neutral. Since the argument is a scientific one, to be conducted exactly as an argument would be conducted about an uncertain experiment. Science depends upon perception and inference. Its credibility is due to the fact that the perceptions are such as any observer can test. The mystic himself may be certain that he knows, but those who are asked to accept his testimony will subject it to scientific tests. Science, as such, should have no expectation, positive or negative, as to the result. The chief argument in favor of the mystics is their agreement with each other. But it is important not to caricature the doctrine of mysticism, in which there is, I think, a core of wisdom. I believe that when the mystics contrast reality with appearance, the word reality has not a logical, but an emotional significance. It means what is, in some sense, important. When it is said that time is unreal, what should be said is that, in some sense and on some occasions, it is important to conceive the universe as a whole, as the Creator, if he existed, must have conceived it in deciding to create it. When so conceived, all process is within one completed whole. Past, present, and future all exist, in some sense, together. And the present does not have that preeminent reality which it has to our usual ways of apprehending the world. If this interpretation is accepted, mysticism expresses an emotion, not a fact. It does not assert anything, and therefore can be neither confirmed nor contradicted by science. The fact that mystics do make assertions is owing to their inability to separate emotional importance from scientific validity. This certain and partial unanimity of mystics is no conclusive reason for accepting their testimony on a matter of fact. The scientist, when he wishes others to see what he has seen, arranges his microscope or telescope. That is to say, he makes changes in the external world, but demands of the observer only normal eyesight. The mystic, on the other hand, demands changes in the observer by fasting, by breathing exercises, and by a careful abstention from external observation. One of the most convincing aspects of the mystic illumination is the apparent revelation of the oneness of all things. An elaborate logic, beginning with Parmenides and culminating in Hegel and his followers, including Karl Marx, has been gradually developed to prove that the universe is one indivisible whole, and that what seems to be its parts, if considered as substantial and self-existing, are mere illusions. The conception of a reality quite other than the world of appearance, a reality one, indivisible and unchanging, was introduced into Western philosophy by Parmenides, not nominally at least for mystical or religious reasons, but on the basis of a logical argument as to the impossibility of not being. Most subsequent metaphysical systems are the outcome of this fundamental idea. Belief in a reality quite different from what appears to the senses arises with irresistible force in certain moods, which are the source of most mysticism and of most metaphysics. While such a mood is dominant, the need of logic is not felt, and accordingly the more thoroughgoing mystics do not employ logic, but appeal directly to the immediate deliverance of their insight. When the intensity of emotional conviction subsides, a person who is in the habit of reasoning will search for logical grounds in favor of the belief which he finds in himself. But since the belief already exists, he will be very hospitable to any ground that suggests itself. The paradoxes apparently proved by his logic are really the paradoxes of mysticism, and are the goal which he feels his logic must reach if it is to be in accordance with insight. The logic of mysticism shows, as is natural, the defects which are inherent in anything malicious. The impulse to logic, not felt while the mystic mood is dominant, reasserts itself as the mood fades, but with a desire to retain the vanishing insight, or at least to prove that it was insight, and that what seems to contradict it is illusion. The logic which thus arises is not quite disinterested or candid, and is inspired by a certain hatred of the daily world to which it is to be applied. Such an attitude naturally does not tend to the best results. Everyone knows that to read an author simply in order to refute him is not the way to understand him. And to read the book of nature with a conviction that it is all illusion is just as unlikely to lead to understanding. If our logic is to find the common world intelligible, it must not be hostile, but must be inspired by a genuine acceptance. In our active life, where we have to exercise choice and to prefer this to that of two possible acts, it is necessary to have distinction of good and evil, or at least of better and worse. But this distinction, like everything pertaining to action, belongs to what mysticism regards as the world of illusion. In our contemplative life, where action is not called for, it is possible to be impartial, and to overcome the ethical dualism which action requires. So long as we remain merely impartial, we may be content to say that both the good and evil of action are illusions. But if, as we must do if we are to have the mystic vision, we find the whole world worthy of love and worship, we shall say that there is a higher good than that of action, and that this higher good belongs to the whole world as it is in reality. In this way, the twofold attitude and the apparent vacillation of mysticism are explained and justified. The possibility of this universal love and joy in all that exists is of supreme importance for the conduct and happiness of life, and gives inestimable value to the mystic emotion, apart from any creeds which may be built upon it. But if we are not to be led into false beliefs, it is necessary to realize exactly what the mystic emotion reveals. It reveals a possibility of human nature, a possibility of a nobler, happier, freer life than any that can otherwise be achieved. But it does not reveal anything about the non-human, or about the nature of the universe in general. Good and bad, and even the higher good that mysticism finds everywhere, are the reflections of our own emotions on other things, not part of the substance of things as they are in themselves. And therefore an impartial contemplation, freed from all preoccupation with self, will not judge things good or bad, although it is very easily combined with that feeling of universal love, which leads the mystic to say that the whole world is good. The hope of satisfaction in our more human desires, the hope of demonstrating that the world has this or that desirable ethical characteristic, is not one which, so far as I can see, a scientific philosophy can do anything whatever to satisfy. The difference between a good world and a bad one is a difference in the particular characteristics of the particular things that exist in these worlds. Ethical interests must remain in the background. Some kind of ethical interest may inspire study, but none must obtrude in the detail or be expected in the special results which are sought. The physicist or chemist is not now required to prove the ethical importance of ions or atoms. In pre-scientific ages, this was not the case. Physics, as it appears in Plato, for example, is full of ethical notions. It is an essential part of its purpose to show that the earth is worthy of admiration. The modern physicist, on the contrary, though he has no wish to deny that the earth is admirable, is not concerned, as physicist, with its ethical attributes. He is merely concerned to find out facts, not to consider whether they are good or bad. In religion, and in every deeply serious view of the world and of human destiny, there is an element of submission, a realization of the limits of human power, which is somewhat lacking in the modern world, with its quick material successes and its insolent belief in the boundless possibilities of progress. The submission which religion inculcates in action is essentially the same in spirit as that which science teaches in thought, and the ethical neutrality by which its victories have been achieved is the outcome of that submission. Human beings cannot, of course, wholly transcend human nature. Something subjective, if only the interest that determines the direction of our attention, must remain in all our thought. But scientific philosophy comes nearer to objectivity than any other human pursuit, and gives us, therefore, the closest constant and the most intimate relation with the outer world that it is possible to achieve. Scientific philosophy represents, though as yet only in a nascent condition, a higher form of thought than any pre-scientific belief or imagination. And, like every approach to self-transcendence, it brings with it a rich reward in increase of scope and breadth and comprehension. A truly scientific philosophy will be more humble, more arduous, offering less glitter of outward mirage to flatter fallacious hopes, but more indifferent to fate, and more capable of accepting the world without the tyrannous imposition of our human and temporary demands. Cosmic purpose. Modern scientists, if they are not hostile or indifferent to religion, cling to one belief which they think can survive amid the wreck of the former dogmas, the belief, namely, of cosmic purpose. The doctrine has several forms, but all have in common the conception of evolution as having a direction towards something valuable, which, in some sense, gives the reason for the whole long process. Many questions are raised by this theory. Let us begin with the most definite. In what sense, if any, is biology reducible to physics? As to the origin of life, the majority of biologists think that living matter is really a physico-chemical mechanism. The Encyclopedia Britannica states, "A living organism, from the point of view of the scientific observer, is a self-regulating, self-repairing, physico-chemical complex mechanism. What we call life is the sum of its physico-chemical processes, forming a continuous interdependent series without break and without the interference of any mysterious extraneous force. Every step in the process is determined by that which preceded it and determines that which follows. As to the origin of life, it must be supposed that long ago, when conditions became favorable, relatively high compounds of various kinds were formed. Many of these would be quite unstable, breaking down almost as soon as formed. Others might be stable and merely persist, but still others might tend to reform, to assimilate as fast as they broke down. Once started on this track, such a growing compound or mixture would inevitably tend to perpetuate itself, and might combine with or feed on others less complex than itself." End of quote. But the question of the relation between physiology and psychology, or body and mind, is even more difficult. There are two distinct questions. Can our bodily behavior be supposed due to physiological causes alone? And what is the relation of mental phenomena to concurrent actions of the body? It is only bodily behavior that is open to public observation. Our thoughts may be inferred by others, but can only be perceived by ourselves. This, at least, is what common sense would say. In theoretical strictness, we cannot observe the actions of bodies, but only certain effects which they have on us. What others observe at the same time may be similar, but will always differ in a greater or less degree from what we observe. For this and other reasons, the gap between physics and psychology is not so wide as was formerly thought. Physics may be regarded as predicting what we shall see in certain circumstances, and in this sense it is a branch of psychology, since our seeing is a mental event. This point of view has come to the fore in modern physics through the desire to make only assertions that are empirically verifiable, combined with the fact that a verification is always an observation by some human being, and therefore an occurrence such as psychology considers. But all this belongs to the philosophy of the two sciences rather than to their practice. their techniques remain distinct, in spite of the rapprochement between their subject matters. As we saw earlier, if our bodily actions all have physiological causes, our minds become causally unimportant. It is only by bodily acts that we can communicate with others or have any effect upon the outer world. What we think only matters if it can affect what our bodies do. Since, however, the distinction between what is mental and what is physical is only one of convenience, our bodily acts may have causes lying wholly within physics, and yet mental events may be among their causes. The practical issue is not to be stated in terms of mind and body. It may perhaps be stated as follows. Are our bodily acts determined by physico-chemical laws? And if they are, is there nevertheless an independent science of psychology in which we study mental events directly, without the intervention of the concept of matter? Neither of these questions can be answered with any confidence, though there is some evidence in favor of an affirmative answer to the first of them. The evidence is not direct. We cannot calculate a person's movements as we can those of the planet Jupiter. But no sharp line can be drawn between human bodies and the lowest forms of life. There is nowhere such a gap as would tempt us to say, here physics and chemistry cease to be adequate. There is no sharp line even between living and dead matter. It seems probable, therefore, that physics and chemistry are supreme throughout. With regard to the possibility of an independent science of psychology, even less can be said at present. To some extent, psychoanalysis has attempted to create such a science, but the success of this attempt, insofar as it avoids physiological causation, may still be questioned. I incline, though with hesitation, to the view that there will ultimately be a science embracing both physics and psychology, though distinct from either as at present developed. The technique of physics was developed under the influence of a belief in the metaphysical reality of matter, which now no longer exists, and the new quantum mechanics has a different technique, which dispenses with false metaphysics. The technique of psychology, to some extent, was developed under a belief in the metaphysical reality of the mind. It seems possible that when physics and psychology have both been completely freed from these lingering errors, they will both develop into one science dealing neither with mind nor with matter, but with events, which will not be labeled either physical or mental. In the meantime, the question of the scientific status of psychology must remain open. Some philosophers maintain that the distinctive concept of psychology is personality. We may take the term as meaning some unifying principle, which binds together the constituents of one mind, causing them all to modify each other. The idea is vague. It stands for the soul, insofar as this is still thought to be defensible. It differs from the soul in not being a bare entity, but a kind of quality of wholeness. It is thought, by those who believe in it, that everything in the mind of John Smith has a John Smithy quality, which makes it impossible for anything quite similar to be in anyone else's mind. If you are trying to give a scientific account of John Smith's mind, you must not be content with general rules, such as can be given for all pieces of matter indiscriminately. You must remember that the events concerned are happening to that particular person, and are what they are because of his whole history and character. There is something attractive about this view, but I see no reason to regard it as true. It is, of course, obvious that two people in the same situation may react differently because of differences in their past histories, but the same is true of two bits of iron, of which one has been magnetized and the other not. Memories, one supposes, are engraved on the brain and affect behavior through a difference of physical structure. The belief that personality is mysterious and irreducible has no scientific warrant, and is accepted chiefly because it is flattering to our human self-esteem. Rather, I am thinking of the actual quality of the subjective experience. Seeing is one thing, recollecting is another. The relations to the past and the future, in psychology as elsewhere, are causal relations, not relations of interpenetration. Memory does not prolong the existence of the past. It is merely one way in which the past has effects. With regard to space, the matter is similar but more difficult. There are two kinds of space, that in which one person's private experiences are situated, and that of physics, which contains other people's bodies, chairs and tables, the sun, moon, and stars, not merely as reflected in our private sensations, but as we suppose them to be in themselves. This second sort is hypothetical and can, with perfect logic, be denied by any person who is willing to suppose that the world contains nothing but his own experiences. As for the subjective kind of space, there is the visual space containing all my visual experience. There is the space of touch. There is, as William James pointed out, the voluminousness of a stomachache, and so on. When I am considered as one thing among a world of things, every form of subjective space is inside me. The starry heavens that I see are not the remote starry heavens of the cosmos, but an effect of the stars on me. What I see is in me, not outside of me. The stars of the cosmos are in physical space, which is outside me, but which I only arrive at by inference, not through analysis of my own experience. The statement that space expresses an order within personality is true of my private space, not of physical space. The accompanying statement that space does not isolate personality would only be correct if physical space also were inside me. The doctrine of cosmic purpose must also contend with the difficulty of explaining the necessity of a temporal evolution. The emergent form of the doctrine of cosmic purpose, which we have next to consider, avoids this difficulty and emphatically upholds the reality of time, according to the theory of emergence. At an earlier stage, nothing in the universe foresees a later stage, but a kind of blind impulsion leads to those changes which bring more developed forms into existence, so that, in some rather obscure sense, the end is implicit in the beginning. I will quote the philosopher Samuel Alexander, who says that inanimate matter, living matter, and mind have appeared successively, and continues. He says, "This growth is one of what is called emergence. Life emerges from matter and mind from life. A living being is also a material being, but one so fashioned as to exhibit a new quality, which is life. And the same thing may be said of the transition from life to mind. A minded being is also a living being, but one of such complexity of development, so finely organized in certain of its parts, and particularly in its nervous system, as to carry mind, or if you please to use the word, consciousness." He goes on to say that there is no reason why this process should cease with mind. On the contrary, and I quote, "It suggests a further quality of existence beyond mind, which is related to mind as mind to life or life to matter. That quality I call deity, and the being which possesses it I call God. It seems to me, therefore, that all things point to the emergence of this quality, and that is why I said that science itself, when it takes the wider view, requires deity. The world is striving or tending to deity, but deity has not in its distinctive nature as yet emerged at this stage of the world's existence." He goes on to say that there is no reason why this process should cease with mind. On the contrary, and I quote, "It suggests a further quality of existence beyond mind, which is related to mind as mind to life or life to matter. That quality I call deity, and the being which possesses it I call God. It seems to me, therefore, that all things point to the emergence of this quality, and that is why I said that science itself, when it takes the wider view, requires deity. The world is striving or tending to deity, but deity has not in its distinctive nature as yet emerged at this stage of the world's existence. He adds that for him, God is not a creator as in religions, but created. There is a close affinity between Samuel Alexander's views and those of Henri Bergson's views in his book, Creative Evolution. Bergson holds that determinism is mistaken because, in the course of evolution, genuine novelties emerge, which could not have been predicted in advance or even imagined. There is a mysterious force which urges everything to evolve. For example, an animal which cannot see has some mystic foreboding of sight and proceeds to act in a way that leads to the development of eyes. At each moment something new emerges, but the past never dies, being preserved in memory, for forgetting is only apparent. Thus the world is continually growing richer in content, and will in time become quite a nice sort of place. The one essential is to avoid the intellect, which looks backward and is static. What we must use is intuition, which contains within itself the urge to creative novelty. I do not suggest that Samuel Alexander accepts Henri Bergson's philosophy in its entirety, but there is a similarity in their views, though they have developed them independently. In any case, their theories agree in emphasizing time and in the belief that, in the course of evolution, unpredictable novelties emerge. Various difficulties make the philosophy of emergent evolution unsatisfactory. Perhaps the chief of these is that, in order to escape from determinism, prediction is made impossible. And yet the adherents of this theory predict the future existence of God. Alexander maintains that we have a vague awareness of deity in some experiences, which he describes as numinous. The feeling which characterizes such experiences is, he says, the sense of mystery, of something which may terrify us or may support us in our helplessness, but at any rate which is other than anything we know by our senses or our reflection. He gives no reason for attaching importance to this feeling, or for supposing that, as his theory demands, mental development makes it become a larger element in life. From anthropologists one would infer the exact opposite. The sense of mystery, of a friendly or hostile non-human force, plays a far greater part in the life of primitive people than in that of civilized people. Indeed, if religion is to be identified with this feeling, every step in known human development has involved a diminution of religion. There have been, it is urged, 3 stages in evolution: matter, life, and mind. We have no reason to suppose that the world has finished evolving, and there is therefore likely, at some later date, to be a 4th phase, and a 5th, and a 6th, and so on, one would have supposed. But no, with the 4th phase, evolution is to be complete. Now, matter could not have foreseen life, and life could not have foreseen mind, but mind can dimly foresee the next stage. It is obvious that all this is the merest guesswork. It may happen to be true, but there is no rational ground for supposing so. The philosophy of emergence is quite right in saying that the future is unpredictable, but having said this, it at once proceeds to predict the future. People are more unwilling to give up the word God than give up the idea for which the word has hitherto stood. Emergent evolutionists, having become persuaded that God did not create the world, are content to say that the world is creating God. But beyond the name, such a God has almost nothing in common with the object of traditional worship. With regard to cosmic purpose in general, in whichever of its forms, there are 2 criticisms to be made. In the first place, those who believe in cosmic purpose always think that the world will go on evolving in the same direction as hitherto. In the second place, they hold that what has already happened is evidence of the good intentions of the universe. Both these propositions are open to question. As to the direction of evolution, the argument is mainly derived from what has happened on this earth since life began. Now, this earth, is a very small corner of the universe. Before the Copernican revolution, it was natural to suppose that God's purposes were specially concerned with the Earth. But now this has become an unplausible hypothesis. If it is the purpose of the cosmos to evolve mind, it is of course possible that there will be more mind later on, or somewhere else. But of this we have no jot of scientific evidence. It may seem odd that life should occur by accident, but in such a large universe, accidents will happen. And even if we accept the rather curious view that the cosmic purpose is specially concerned with our little planet, we still find that there is reason to doubt whether it intends quite what the theologians say it does. The Earth is likely to remain habitable for some considerable time, but not forever. A million years gives us some time to prepare for the end, and we may hope that in the meantime both astronomy and space travel will have made considerable progress. We may have discovered another star with habitable planets, and be able to fire ourselves off to it with a speed approaching that of light. Cruising around the universe, however, even if it is to come with the most perfect scientific skill, cannot prolong life forever. The second law of thermodynamics tells us that, on the whole, energy is always passing from more concentrated to less concentrated forms, and that, in the end, it will have all passed into a form in which further change is impossible. When that has happened, if not before, life must cease. That mind is the only reality, and that the spaces and times of the cosmos are created by it, there is much to be said about this. But those who adopt it in the hope of escaping from depressing conclusions do not quite realize what it entails. Everything that I know directly is part of my mind, and the inferences by which I arrive at the existence of other things are by no means conclusive. It may be, therefore, that nothing exists except my mind. In that case, when I die, the universe will go out. But if I am going to admit minds other than my own, I must admit the whole cosmological universe, since the evidence is exactly equally strong in both cases. Against any form of the doctrine that mind is the only reality, there is the fact that our evidence for other people's minds is derived by inference from our evidence for their bodies. Other people, therefore, if they have minds, have bodies. Oneself alone may possibly be a disembodied mind, but only if oneself alone exists. I come now to the last question in our discussion of cosmic purpose, namely, is what has happened hitherto evidence of the good intentions of the universe? The alleged ground for believing this, as we have seen, is that the universe has produced us. I cannot deny it, but are we really so splendid as to justify such a long prologue? The philosophers lay stress on values. They say that we think certain things good, and that since these things are good, we must be very good to think them so. But this is a circular argument. A being with other values might think ours so atrocious as to be proof that we were inspired by Satan. Is there not something a trifle absurd in the spectacle of human beings holding a mirror before themselves and thinking what they behold so excellent as to prove that a cosmic purpose must have been aiming at it all along? The human species, as a curious accident in a backwater, is intelligible. This mixture of virtues and vices is such as might be expected to result from a fortuitous origin. But only abysmal self-complacency can see in the human species a reason which omniscience could consider adequate as a motive for the Creator. Determinism. Determinism has a twofold character. On the one hand, it is a practical maxim for the guidance of scientific investigators. On the other hand, it is a general doctrine as to the nature of the universe. The practical maxim may be sound, even if the general doctrine is uncertain. Let us begin with the maxim and proceed afterwards to the doctrine. The maxim advises people to seek causal laws, that is to say, rules connecting events at one time with events at another. In everyday life, we guide our conduct by rules of this sort, but the rules that we use purchase simplicity at the expense of accuracy. Such rules will not do for science, which wants something invariable. Its ideal was fixed by Newtonian astronomy, where, by means of the law of gravitation, the past and future positions of the planets can be calculated throughout periods of indefinite vastness. The search for laws governing phenomena has been more difficult elsewhere than in relation to the orbits of the planets, because elsewhere there is a greater complexity of causes of different kinds, and a smaller degree of regularity of periodic recurrence. Nevertheless, causal laws have been discovered in chemistry, in electromagnetism, in biology, and even in economics. The discovery of causal laws is the essence of science, and therefore there can be no doubt that scientists do right to look for them. If there is any region where there are no causal laws, that region is inaccessible to science. But the maxim that scientists should seek causal laws is as obvious as the maxim that mushroom gatherers should seek mushrooms. Determinism, as a general doctrine, asserts that complete determinism of the future by the past is always possible, theoretically, if we know enough about the past and about causal laws. The investigator, observing some phenomenon, should, according to this principle, be able to find previous circumstances and causal laws which together made the phenomenon inevitable. And, having discovered the laws, he should be able, when he observes similar circumstances, to infer that a similar phenomenon is going to occur. An omniscient God, such as the Orthodox believe in, must now know the whole course of the future. There is, therefore, if an omniscient God exists, a present fact, namely, his foreknowledge, from which the future could be inferred. This, however, lies outside what can be scientifically tested. If this doctrine of determinism is to assert anything that can be made probable or improbable by evidence, it must be stated in relation to our human powers. If we are to have a doctrine that can be tested, it is not enough to say that the whole course of nature must be determined by causal laws. This might be true, and yet undiscoverable. For example, if what is more distant had more effect than what is nearer, for we should then need a detailed knowledge of the most distant stars before we could foresee what was going to happen on Earth. If we are to be able to test our doctrine, we must be able to state it in relation to a finite part of the universe, and the laws must be sufficiently simple for us to be able to make calculations by their means. We cannot know the whole universe, and we cannot test laws which are so complicated as to require more skill than we can hope to possess for the working out of their consequences. The powers of calculation involved may exceed what is possible at the moment, but not what may probably be acquired before long. This point is fairly obvious, but there is more difficulty in stating our principle so as to be applicable when our data are confined to a finite part of the universe. Things from outside may always crash in and have unexpected effects. Sometimes a new star appears in the heavens, and these appearances cannot be predicted from the data confined to the solar system. And as nothing travels faster than light, there is no way by which we can get an advance message telling that a new star is going to appear. For the first time in history, determinism is now being challenged on scientific grounds. The challenge has come through the study of the atom by the new methods of quantum mechanics. According to quantum mechanics, it cannot be known what an atom will do in given circumstances. There are a definite set of alternatives open to it, and it chooses sometimes one, sometimes another. We know in what proportion of cases one choice will be made, in what proportion a second or a third, and so on. But we do not know any law determining the choice in an individual instance. No one can deny that laws may be discovered which will show why an atom chooses one possibility on one occasion and another on another. At present, we know of no relevant difference in the antecedents of the two different choices, but some such difference may be found any day. If we had any strong reason to believe in determinism, this argument would carry great weight. Unfortunately for the determinists, there is a further step in the modern doctrine of atomic caprice. We had, or so we thought, a great mass of evidence from ordinary physics tending to prove that bodies always move in accordance with laws which completely determine what they will do. It now appears that all these laws may be merely statistical. The atoms choose among possibilities in certain proportions, and they are so numerous that the result, as regards bodies large enough to be observed by old-fashioned methods, has an appearance of complete regularity. Suppose you were a giant who could not see individual people, and never became aware of an aggregate of less than 1,000,000 of them. You would just be able to notice that London contains more matter by day than by night. But you could not possibly be aware of the fact that on a given day Mr. Dixon was ill in bed and did not take his usual train. You would therefore believe the movement of matter into London in the morning and out of it in the evening to be a much more regular affair than it is. You would no doubt attribute it to some peculiar force in the sun, a hypothesis which would be confirmed by the observation that the movement is retarded in foggy weather. If later you became able to observe individual people, you would find that there is less regularity than you had supposed. One day Mr. Dixon is ill, and another Mr. Simpson. The statistical average is not affected, and to a large-scale observation there is no difference. You would find that all the regularity you had previously observed could be accounted for by the statistical law of large numbers, without supposing that Mr. Dixon and Mr. Simpson had any reason beyond caprice for their occasional failure to go to London in the morning. This is exactly the situation at which physics has arrived in regard to atoms. It does not know of any laws completely determining their behavior, and the statistical laws which it has discovered are sufficient to account for the observed regularity in the motions of large bodies. And as the case for determinism has rested on these, it seems to have broken down. What quantum theory assumes as regards individual atoms is a law of probability. Of the possible choices open to the atom, there is a known probability of one, another known probability of a second, and so on. From this law of probability, it can be inferred that large bodies are almost certain to behave as traditional mechanics expect. The observed regularity of large bodies, therefore, is only probable and approximate, and affords no inductive ground for expecting a perfect regularity in the doings of individual people. What is new in quantum mechanics is not the occurrence of statistical laws, but the suggestion that they are ultimate, instead of being derived from laws governing individual occurrences. This is a very difficult conception, more difficult, I think, than its supporters realize. It has been observed that of the different things an atom may do, it does each a certain proportion of cases. But if the single atom is lawless, why should there be this regularity as regards large numbers? There must, one would suppose, be something that makes the rare transitions depend upon some unusual set of circumstances. Now, the laws of large-scale mechanics, as we have seen, are unchanged by the new theories as to the atom. The only difference is that they now state overwhelming probabilities instead of certainties. It is possible to imagine these probabilities counteracted by some peculiar kind of instability, owing to which a very small force might produce a very large effect. This sort of instability may exist in living matter, and more particularly in the brain. An act of volition may lead one atom to this choice rather than that, which may upset some very delicate balance, and so produce a large-scale result, such as saying one thing rather than another. It cannot be denied that this is abstractly possible, but that is the most that can be conceded. It is also a possibility, and to my mind a much more probable one, that new laws will be discovered which will abolish the supposed freedom of the atom. And even granting the freedom of the atom, there is no empirical evidence that large-scale movements of human bodies are exempt from the process of averaging, which makes traditional mechanics applicable to the movements of other bodies of appreciable size. The search for causal laws, as we saw, is the essence of science, and therefore, in a purely practical sense, the person of science must always assume determinism as a working hypothesis, But he is not bound to assert that there are causal laws except where he has actually found them. Indeed, he is unwise if he does so. But he is still more unwise if he asserts positively that he knows of a region where causal laws do not operate. This assertion has an unwisdom at once theoretical and practical. Theoretical, because our knowledge can never be sufficient to warrant such an assertion, and practical, because the belief that there are no causal laws in a certain province discourages investigation and may prevent laws from being discovered. This double unwisdom seems to me to belong both to those who assert that changes in atoms are not completely deterministic, and to those who dogmatically assert free will. Faced with such opposite dogmatisms, science should remain purely empirical, carrying neither assertion nor denial beyond the point warranted by actual evidence. Perennial controversies, such as that between determinism and free will, arise from the conflict of two strong but logically irreconcilable passions. Determinism has the advantage that power comes through the discovery of causal laws. Science, in spite of its conflict with theological prejudice, has been accepted because it gave power. Belief that the course of nature is regular also gives a sense of security. It enables us, up to a point, to foresee the future and to prevent unpleasant occurrences. When illness and storms were attributed to capricious diabolical agencies, they were much more terrifying than they are now. All these motives lead people to determinism. But while they like to have power over nature, they do not like nature to have power over them. If they are obliged to believe that before the human race existed, laws were at work which, by a kind of blind necessity, produced not only people in general, but oneself, with all one's idiosyncrasies, saying and doing at this moment whatever one is saying and doing, they feel robbed of personality, futile, unimportant, the slaves of circumstance, unable to vary in the slightest degree the part assigned to them by nature from the very beginning. From this dilemma, some people seek to escape by assuming freedom in human beings and determinism everywhere else. Others by ingeniously sophisticated attempts at a logical reconciliation of freedom with determinism. In fact, we have no reason to adopt either alternative, but we also have no reason to suppose that the truth, whatever it may be, is such as to combine the agreeable features of both, or is, in any degree, determinable by relation to our desires. Science and ethics. Those who maintain the insufficiency of science appeal to the fact that science has nothing to say about value. As there is no consensus of opinion about ethics, it must be understood that what follows is my personal belief, not the dictum of science. The study of ethics traditionally consists of two parts, one concerned with moral rules, the other with what is good on its own account. Rules of conduct, many of which have a ritual origin, play a great part in the lives of all peoples. Rules, such as the prohibition of murder and theft, have an obvious social utility, and survive the decay of the theological systems with which they were originally associated. But as people grow more reflective, there is a tendency to lay less stress on rules and more on states of mind. This comes from two sources, philosophy and mystical religion. What they value is a state of mind, out of which, as they hold, right conduct must ensue. Rules seem to them external and insufficiently adaptable to circumstances. One of the ways in which the need of appealing to external rules of conduct has been avoided has been the belief in conscience. It has been supposed that God reveals to each human heart what is right and what is wrong, so that, in order to avoid sin, we have only to listen to the inner voice. There are, however, two difficulties in the theory. First, that conscience says different things to different people. Secondly, that the study of the unconscious has given us an understanding of the mundane causes of conscientious feelings. The diversity and the deliverances of conscience is what is to be expected when its origin is understood. In early youth, certain classes of acts meet with approval and others with disapproval, and by the normal process of association, pleasure and discomfort gradually attach themselves to the acts, and not merely to the approval and disapproval respectively produced by them. As time goes on, we may forget all about our early moral training, but we shall still feel uncomfortable about certain kinds of actions, while others will give us a glow of virtue. To introspection, these feelings are mysterious, since we no longer remember the circumstances which originally caused them, and therefore it is natural to attribute them to the voice of God in the heart. But in fact, conscience is a product of education, and can be trained to approve or disapprove, in the great majority of cases, as educators see fit. While, therefore, it is right to wish to liberate ethics from external moral rules, this can hardly be satisfactorily achieved by means of the notion of conscience. Questions as to values, that is to say, as to what is good or bad on its own account, independently of its effects, lie outside the domain of science, as the defenders of religion emphatically assert. I think that in this they are right, but I draw the further conclusion, which they do not draw, that questions as to values lie wholly outside the domain of knowledge. That is to say, when we assert that this or that has value, we are giving expression to our own emotions, not to a fact, which would still be true if our personal feelings were different. It is obvious, to begin with, that the whole idea of good and bad has some connection with desire. Anything that we all desire is good, and anything that we all dread is bad. If we all agreed in our desires, the matter could be left there. But unfortunately our desires conflict. If I say, what I want is good, my neighbor will say, no, what I want is good. Ethics is an attempt, though not, I think, a successful one, to escape from this subjectivity. I shall naturally try to show, in my dispute with my neighbor, that my desires have some quality which makes them more worthy of respect than his. Ethics is an attempt to give universal, and not merely personal, importance to certain of our desires. Ethics contains no statements, whether true or false, but consists of desires of a certain general kind, namely such as are concerned with the desires of humankind in general. Science can discuss the causes of desires and the means for realizing them, but it cannot contain any genuinely ethical sentences, because it is concerned with what is true or false. The theory I have been advocating is a form of the doctrine which is called the subjectivity of values. This doctrine consists in maintaining that if two people differ about values, there is not a disagreement as to any kind of truth, but a difference of taste. The consequences of this doctrine are considerable. In the first place, there can be no such thing as sin in any absolute sense. What one person calls sin, another may call virtue, and though they may dislike each other on account of this difference, neither can convict the other of intellectual error. Punishment cannot be justified on the ground that the criminal is wicked, but only on the ground that he has behaved in a way which others wish to discourage. Hell, as a place of punishment for sinners, becomes quite irrational. The more general consequences which are feared, such as the decay of all sense of moral obligation, are to be logically deduced. Moral obligation, if it is to influence conduct, must consist not merely of a belief, but of a desire. Such desires can, no doubt, be encouraged by example, education, and knowledge, but they can hardly be created by the mere abstract belief that they are good, nor discouraged by an analysis of what is meant by the word good. When we contemplate the human species, we may desire that it should be happy, or healthy, or intelligent, or warlike, and so on. Any one of these desires, if it is strong, will produce its own morality. But if we have no such general desires, our conduct, whatever our ethic may be, will only serve social purposes insofar as self-interest and the interests of the society are in harmony. It is the business of wise institutions to create such harmony as far as possible. And for the rest, whatever may be our theoretical definition of value, we must depend upon the existence of impersonal desires. Our desires are, in fact, more general and less purely selfish than many moralists imagine. If it were not so, no theory of ethics would make moral improvement possible. It is, in fact, not by ethical theory, but by the cultivation of large and generous desires through intelligence, happiness, and freedom from fear, that people can be brought to act more than they do at present, in a manner that is consistent with the general happiness of humankind. Whatever our definition of the good, and whether we believe it to be subjective or objective, those who do not desire the happiness of humanity will not endeavor to further it, while those who do desire it will do what they can to bring it about. The scientific temper of mind is cautious, tentative, and piecemeal. It does not imagine that it knows the whole truth, or that even its best knowledge is wholly true. It knows that every doctrine needs emendation sooner or later, and that the necessary emendation requires freedom of investigation and freedom of discussion. But out of theoretical science, a scientific technique has developed, and the scientific technique has none of the tentativeness of a theory. Physics has been revolutionized during the present century by relativity and the quantum theory. But all inventions based upon the old physics are still found satisfactory. The practical experts who employ scientific technique, and still more the governments and large firms which employ the practical experts, acquire a quite different temper from that of the scientists, a temper full of a sense of limitless power, of arrogant certainty, and of pleasure in manipulation. This is the very reverse of the scientific temper, but it cannot be denied that science has helped to promote it. The direct effects of scientific technique have been by no means wholly beneficial. On the one hand, they have increased the destructiveness of weapons of war. On the other hand, by increasing the productivity of labor, they have made the old economic system, which depended upon scarcity, very difficult to work with. And by the violent impact of new ideas, they have thrown ancient civilizations off their balance. The warfare between science and theology, in spite of an occasional skirmish on the outposts, is nearly ended. And I think most religious people would admit that their religion is the better for it. Christianity has been purified of inessentials inherited from a barbarous age, and nearly cured of the desire to persecute. But while the older religions have thus become purified, and in many ways beneficial, new religions have arisen, with all the persecuting zeal, and with as great a readiness to oppose science as characterized by the Inquisition. The persecution of intellectuals by totalitarian regimes has surpassed, in severity, anything perpetrated by the churches during the last 250 years. It may be urged that persecution in our day, unlike the past, is political and economic rather than theological. But such a plea would be unhistorical. Economic and political motives have always been a part cause of persecution, perhaps even the main cause. In any case, the argument against the persecution of opinion does not depend upon what the excuse for persecution may be. The argument is that we none of us know all truth, that the discovery of new truth is promoted by free discussion, and rendered very difficult by suppression, and that, in the long run, human welfare is increased by the discovery of truth, and hindered by action based on error. New truth is often inconvenient to some vested interest, but it is in the interest of the community at large that new truth should be freely promulgated. Those to whom intellectual freedom is personally important may be a minority in the community, but among them are the people of most importance to the future. New truth is often uncomfortable, especially to the holders of power. Nevertheless, amid the long record of cruelty and bigotry, it is the most important achievement of our intelligent but wayward species. Science and education. Science, to the ordinary reader of newspapers, is represented by a varying selection of sensational triumphs. It is not of this aspect of science that I wish to speak. Science in this aspect consists of detached, up-to-date fragments, interesting only until they are replaced by something newer and more up-to-date, displaying nothing of the systems of patiently constructed knowledge out of which, almost as a casual incident, have come the practically useful results which interest the general public. The increased command over the forces of nature which is derived from science is undoubtedly an amply sufficient reason for encouraging scientific research, but this reason has been so often urged and is so easily appreciated that other reasons, to my mind quite as important, are apt to be overlooked. It is with these other reasons, especially with the intrinsic value of a scientific habit of mind in forming our outlook on the world, that I shall be concerned in what follows. In the broader sense, education will include not only what we learn through instruction, but all that we learn through personal experience, the formation of character through the education of life. In the narrower sense, education may be confined to instruction, the imparting of definite information on various subjects, because such information in and for itself is useful in daily life. But instruction, necessary as it is, does not per se constitute education in the sense in which I wish to consider it. Education, in the sense in which I mean it, may be defined as the formation, by means of instruction, of certain mental habits and a certain outlook of life and the world. It remains to ask ourselves what mental habits and what sort of outlook can be hoped for as the result of instruction. When we have answered this question, we can attempt to decide what science has to contribute to the formation of the habits and outlook which we desire. Our whole life is built about a certain number, not a very small number, of primary instincts and impulses. Only what is in some way connected with these instincts and impulses appears to us desirable or important. There is no faculty, whether reason or virtue, or whatever it may be called, that can take our active life and our hopes and fears outside the region controlled by these first movers of all desire. All meaning must be at bottom related to our primary desires, and when they are extinct, no miracle can restore to the world the value which they reflected upon it. The purpose of education, therefore, cannot be to create any primary impulse which is lacking in the uneducated. The purpose can only be to enlarge the scope of those that human nature provided, by increasing the number and variety of attendant thoughts, and by showing where the most permanent satisfaction is to be found. But although nature must supply the initial force of desire, nature is not, in the civilized person, the spasmodic, fragmentary, and yet violent set of impulses that it can be in the uncivilized person. Each impulse has its constitutional ministry of thought and knowledge and reflection, through which possible conflicts of impulses are foreseen. Temporary impulses are controlled by the unifying impulse which may be called wisdom. In this way, education destroys the crudity of instinct and increases, through knowledge, the wealth and variety of the individual's contacts with the world, making him no longer an isolated fighting unit, but a citizen of the universe, embracing remote regions of space and vast stretches of past and future within the circle of his interests. It is this simultaneous softening of the insistence of desire and enlargement of its scope that is the chief moral end of education. Closely connected with this moral end is the purely intellectual aim of education, the endeavor to make us see and imagine the world in an objective manner, as far as possible as it is in itself, and not merely through the distorting medium of personal desire. The complete attainment of such an objective view is no doubt an ideal, indefinitely approachable, but not actually and fully realizable. Education, considered as a process of forming our mental habits and our outlook on the world, is to be judged successful in proportion as its outcome approximates to this ideal. If this standard is admitted, we can return to the consideration of science, inquiring how far science contributes to such an aim, and whether it is in any respect superior to other educational practices. The discovery of scientific method has already transformed the world, and its success proceeds with ever-accelerating velocity. No transcendent ability is required in order to make useful discoveries in science. The edifice of science needs its masons, bricklayers, and common laborers, as well as its foremen, master builders, and architects. In science, even a very moderate capacity can contribute to a supreme achievement. In science, the person of real genius is the person who invents a new method, The notable discoveries are often made by the successors, who can apply the method with fresh vigor, unimpaired by the previous labor of perfecting it. But the mental caliber of the thought required for their work, however brilliant, is not so great as that required by the first inventor of the method. There are in science immense numbers of different methods, appropriate to different classes of problems, but over and above them all there is something so easily definable which may be called the method of science. It was formerly customary to identify this with the inductive method, but the true method of science is something which includes deduction as much as induction, logic and mathematics as much as botany and geology. The kernel of the scientific outlook is a thing so simple, so obvious, so seemingly trivial, that the mention of it may almost excite derision. The kernel of the scientific outlook is the refusal to regard our own desires, tastes, and interests as affording a key to the understanding of the world. Stated thus baldly, this may seem no more than a trite truism. But to remember it consistently in matters arousing our passionate partisanship is by no means easy, especially where the available evidence is uncertain and inconclusive. Aristotle considered that the stars must move in circles because the circle is the most perfect curve. In the absence of evidence to the contrary, he allowed himself to decide a question of fact by appeal to aesthetico-moral considerations. In such a case, it is at once obvious to us that this appeal was unjustifiable. We know now how to ascertain as a fact the way in which the heavenly bodies move, and we know that they do not move in circles, or even in accurate ellipses, or in any other kind of simply describable curve. This may be painful to a certain hankering after simplicity of pattern in the universe, but we know that in astronomy such feelings are irrelevant. Easy as this knowledge seems now, we owe it to the courage and insight of the first inventors of scientific method, and more especially to Galileo. Under the influence of Darwinism, the scientific attitude towards humanity has now become fairly common, and is to some people quite natural, though to most it is still a difficult and artificial contortion. The scientific attitude of mind involves a sweeping away of all other desires in the interests of the desire to know. It involves suppression of hopes and fears, loves and hates, and the whole subjective emotional life, until we become subdued to the material, able to see it frankly, without preconceptions, without bias, without any wish except to see it as it is, and without any belief that what it is must be determined by some relation, positive or negative, to what we should like it to be, or to be what we can easily imagine it to be. A certain self-absorption, not personal, but human, has marked almost all attempts to conceive the universe as a whole. Mind, or some aspect of it, thought, or will, or sentience, has been regarded as the pattern after which the universe is to be conceived, for no better reason at bottom than that such a universe would not seem strange, and would give us the cozy feeling that every place is essentially like home. To conceive the universe as essentially progressive or essentially deteriorating, for example, is to give to our hopes and fears a cosmic importance, which may, of course, be justified. Until we have learned to think of it in ethically neutral terms, we have not arrived at a scientific attitude. The instinct of constructiveness, which is one of the chief incentives to artistic creation, can find in scientific systems a satisfaction more massive than any epic poem. Curiosity, which is the source of almost all intellectual effort, finds with astonished delight that science can unveil secrets which might well have seemed forever undiscoverable. The desire for a larger life and wider interests, for an escape from solitary circumstances, and even from the whole recurring human cycle of birth and death, is fulfilled by the impersonal cosmic outlook of science as by nothing else. To all these must be added, as contributing to the happiness of the person of science, the admiration of splendid achievement and the consciousness of inestimable utility to the human species. A life devoted to science is therefore a happy life, and its happiness is derived from the very best sources that are open to dwellers on this troubled and passionate planet. This is David Case for Audio Scholar. Thank you for listening.